Here is our Civilink model, and here is the reinforcement learning training monitor. The pendulum is also loaded out here. So I'm attaching these three windows to show exactly how our system is functioning. So yeah. As you can see, the pendulum is going in a normal fashion, which is the the normal oscillations which would take place, and each episode would be recorded with its episode number and its reward. As you can see, the first episode is done, so then this is the average reward and your episode reward, which is going to be done over here. Your episode rewards are kind of on the decreasing curve right now, but if you see as soon as we start with the evaluation statistic, this would start to stabilizing. Yeah. As soon as we have our evaluation statistic, which as shown over here is the mean episode reward, your observations start to stabilize, and it would then record the angle at which it would basically stay upright. Now the thing is, the evaluation statistic would as soon as the evaluation statistic reaches to 0, then we would realize that the pendulum is upright. So let's see how long will it take. Now, since this is a built-in simple pendulum model from the reinforcement learning toolbox, it would not take much episodes. It would take less than 100 episodes for sure. But let's check it out. This is very much if you people are thinking where the reinforcement learning models are executed, these are executed in the CPU, not in the GPU, because there's a setting in MATLAB to do it for the GPU or the CPU, and currently I just set it to the CPU, so then it would be you know it would be consuming lesser resources in general. I do not want my MATLAB to be consuming a lot of my GPUs because I use my GPUs for other stuff. As you can see, with each episode number, the pendulum is trying to go beyond the 180-degree mark, or what could I say in relation to this? This would be a 90-degree one. It's basically trying to go beyond this. Let's see how that happens. Yep, it is now coming pretty close to our expected values. And as you can see, the pendulum is now trying to go upright. Yep, it started going upright now, but it is not staying at that position, so it would now start finding the reward for making it at that position. This is a really interesting way to visualize how reinforcement learning actually is working. Yep, it is now doing a complete 360 degrees, and it would continue doing a 360 degree unless and until it finds the point at which it should stabilize. At one moment you can see the episode reward has gone way down. It's, I think so, the 55th episode. And it'll keep on going, doing a 360 unless and until it stabilizes it above. as you can see above the 50, above, as soon as it goes above 60 episodes, it's trying to get it upright. Yeah, as you can see from the 65th episode, it has started getting it upright. Yep. At the 67th episode, it is getting it straight. 68th episode. Okay. In the 69th episode, it got it up straight. Yeah, it is keeping it stably above. At the 70th episode, it's still keeping it stably above. Oh wait, it's 69th still. And yeah, at the 70th episode, it stopped. So this is how you would train it for reinforcement learning. Now let me show you how. Wait a minute, training stopped. It's still not stopped. Sorry. It's still at the. Yep, at the 70th episode. It should be probably over. Yep, it is. Okay, good. This is how you get your model trained. Now, the most important part, which is very important for embedded engineers, is to generate a C code from this, so that we can deploy this to hardware. There are certain things to keep in mind. I have stored this .m file into an agent, which basically would record all of these values, and this would record all of the episodes and everything, like the episode reward, your at which point the pendulum is upright and stuff. It would just record all of that into the agent variable, and we would now start going with the generation for the C code. Just give me a moment. Okay, so the way we generate the C code is, we first, from this agent, whatever recordings we have, we need to generate a policy. What is a policy exactly? The policy for this model would be the iteration at, or the episode number at which this pendulum is completely upright. And as you can see at the 70th episode, this is completely upright. So we just need to generate the C code for the model and to which this thing works perfectly. Okay. I agree that many people would think this is not the actual way machine learning works and stuff, but since this is not actually being deployed to a hardware, or this is not actually doing a machine learning on the microcontroller, or on the, and that would not happen on the microcontroller, but on an SBC like an RPi or B Group Black. So in theory, we can assume that the C code generated by the MATLAB or Simulink should work inside of your hardware. And I'm going to be using the MATLAB coder to generate this C code. This is completely based out of MATLAB's own like method of generating this code. So how do we generate the policy from this agent? We generate it through a generate policy block. So this is basically a wait. So this is basically a way of getting our for getting the proper deployment block at which the 70th episode block at which your Simulink model would keep the pendulum upright. And yep, here we have it. This is your policy block, and what we do with this is that I'll just press Ctrl E. So we need to generate a C code from this. But before we do that, we have to combine this with your simple pendulum reinforcement learning model. So I would save this as a different thing. So I don't want to disturb this because this is your MATLAB models, and I've had an experience of basically overwriting that. So I would rather go to the path of which I would be needing it for my presentation. I just name a folder, open, and this would be deployment. I would name this differently. Yeah, I would not want to mix it up with MATLAB's models, or else this would cause a problem. So how do I generate the C code? Now before I do that, I would close these windows, the windows for the reinforcement learning agent, as well as your I don't even need this. So how would I do this? Basically I'm gonna delete this part, comment out, where's delete? That's not delete. So I'll just press the delete button. Probably should work. Yeah, okay. So I'll take the policy, which is this one, and I'll save this first to C deployment. Okay, wait a minute. I would probably not use this one, episode policy 70. Much better. Okay, I need to first copy this, and this is my photos, and I would deploy it here. So we don't need the reward, since this is a policy. The calculate reward function is not required anymore. What we do need is your observation, which I'm going to connect it here. I'll just move this a bit down. I can move. Yeah, it's okay. And then there's the action, which I'm going to move it into here. Now I'll just save this. As soon as I run this model, what you should see is that the pendulum should stay upright. Okay, so for this I would go to Control E and select a value for the stop time. TF is usually the value I set it up in the MATLAB code, so I need to check it. Okay, it's 20. So 20 is the value. I would put it a fixed step size. Wait, and I will go with wait. I don't remember which solver we used for this. There are many different ways of doing that. Okay, so I don't know why, but we would usually use this one ODE3. Any mathematicians in my comment box could explain me why, and I'd keep the step size as same as the MATLAB one. 0.05 would be that sample time, but here the sample time and step size is the same thing. And if people ask me why that's the same thing, I'd tell them to go study signal processing and apply, make it okay, and restart the model. Yeah, this is a normal. We don't need to connect that. So we can ignore this warning. And as you can see, yeah, this is shaking a bit, which basically means this is keeping it at that position. Yeah. Close this. Now, I would go again to this. Wait. Oh, sorry. Control E, the configuration parameters. We'll go to code generation. I would first browse the system target file. Generic real time. I would rather go with this one. Let's see. Apply. I'm not sure this would work though, but yeah. Or this one. Embedded coder would be better. MSVC build. Okay. And you need the coded directory. Okay. I would need to set that up. Okay. This is not what I thought. Okay. But apply. Okay. And now I would press Control B for building this. Let's see how does it compile. That's a that's a version warning, but okay. This is taking some time, but I use the Visual Studio solution because I usually use Visual Studio for doing my stuff. So yeah. Okay. There's a build error. What is it? It's continuous time. Don't ask me why I like Visual Studio. It's mostly a Microsoft thing. It usually takes some time. MATLAB usually is pretty slow. Even if you have a gaming laptop. Don't ask me why. I sometimes get really irritated at times seeing this. Okay, it looks like the C code was generated. Let us look at that. I'll also open the MATLAB report. Wow, okay. Look at this. This is the C code. This is generated. Several different files are there. The deployment.c. There's a deployment.h. But honestly, there's some there's a need for some debugging and which part of the code goes where. That's pretty important. So yeah, this is the report. Let's check this out. Subsystem report. Code interface report. Yeah. Um, this is an interesting thing. MATLAB generates you this kind of report which talks about these functions. Okay, and then you have a traceability report. Yeah, you don't need these. Okay, I wish we had these, but okay, I would check that out as to why this is not there. But overall, I believe uh, we have met all of the requirements which was the setup in the embedded control course. So, thanks for watching.